In this video, we're going to look at algebra. Before we look at algebra, we look at these concepts that we use in algebra. We look at signs. So, what is the answer of 3 plus 2? Everybody knows that's 5. Why is that 5? What is the answer of minus 3 minus 2? Now many of you will say a negative and a negative is a positive, but you're not multiplying. Here is a concept we have to look at. Are you multiplying? No. So the answer is minus 5. Why? Because when operating on terms with the same signs, we add the term and retain the sign. So this will be 1 plus 2, 3 plus 3, 6 plus 4 is 10. So the answer is minus 10, and this will be a positive 10. So whenever you're operating on terms with different signs, you same sign, you add a term and retain the sign. In the second case here, we call this concept 2. 3 minus 2 is 1. And the same thing, you can put the 2 in front. Minus 2 plus 3 is still 1 because of the law of associativity. 4 minus 9 plus 4 is minus 5. Because when operating on terms with different signs, many will look at the sign in the middle. We don't look at the sign in the middle. We look at the sign of the term. Do they have the same sign? No, they have different signs. So what do? We subtract them, and the answer take the sign of the larger term. This will be minus 1. So we look at another set of concepts. What happens when you have minus 2? What happens when you have minus 2 and a minus outside of the bracket? Well, in this case, you can say that you're multiplying the bracket by minus 1. So the answer will be positive 2. This will be a positive x. And again, as I said, it's like you multiplying the bracket by minus 1. So again, this will be a positive 2. When there's a negative and a positive sign separated by a bracket, the answer is negative, whether the negative is outside or inside the bracket. So remember those two concepts on the other page, and remember these as well. So for multiplication, you see, when multiplying terms with the same sign, minus 1 times minus 1, the answer is positive 1. Right, if you are not multiplying the terms, what's going on with my phone, man? Hey, give me a sec. Sorry about that. Only when you're multiplying terms, minus 1 times minus 1, the answer will be positive. And a positive times a positive, the answer is still positive. When a negative times a positive, the answer is negative. And when a positive times a negative, the answer is negative. What will happen here when you're multiplying three terms with the same sign? Minus 1 times minus 1 times minus 1. Well, minus 1 times minus 1 is positive 1, and times minus 1. And then the answer is a minus 1. So when multiplying terms with the same sign, the answer is positive. And when multiplying terms with different signs, the answer is negative. Remember that. So here, what are we going to deal with algebra? This is the basics of algebra, the fundamentals. These are some of the things that you need to know. Okay, this is the algebraic term, 2x cubed. This 2 is called a coefficient, and when operating in algebra, the four basic multiplication, division, addition, and subtraction, those can change the coefficient. But for the power, only multiplication and division can change that. So as long as you're adding, you can change the power. So you can say x plus x is x squared, because you're adding. It's not supposed to change the power. It's supposed to change the coefficient. So you can have x plus x is 2x. Okay, so here we have addition of and subtraction of algebraic terms. So x plus x, as I explained just now, is 2x because addition does not change the power. Y plus y is 2y. There's a 1 in front of the x. It's understood, so we don't put it. So 1 plus 1 is 2. R plus R is 2R. So how do we add terms in algebra? Only like terms can be added or subtracted. And what are like terms? Like terms are terms with the same base, same variable, and the same power. If they don't have the same power, they are unlike terms. You cannot add them. So can this be added? They have the same base, x and x. Do they have the same power? Yes. 1 and 1. But again, the 1 is understood, so we don't put it back. So we can add this, and we'll get 2 plus 3, or 2x plus 3x is 5x. Can we subtract these? Yes, we can. They have the same base and the same power. And remember the concepts we did before? When operating on terms with different sign, this is a positive, this is a negative. We subtract the term, and the answer take the sign of the larger term. So this will be a minus y. 5 from 6 is 1. And we have a minus, the larger term was minus, so this is a minus y. When operating on terms with the same sign, we add the term and retain the sign. So this answer is a minus 5x. I would like you to pause and then try to solve the other two before you continue the video. I'll start now. So these two, again, we did this concept on the other side here. Let me show you. When there's two negatives in front of a bracket, or negative separates the bracket, then the answer becomes positive. So this is minus 5x plus 2x. So now again we're operating on terms with different signs. So this becomes a minus 3x. We subtract the term and the answer take the sign of the larger term. This here is 3x minus x, which will give us 2x, because we operating on terms with different sign, and the negative and the positive separated by a bracket becomes a negative. Alright, so on to the next page. For more exercise, for more examples, if you want more exercise example, you can go to page 234 in volume 1. That's the blue text. So x plus y, many of you will say, oh, this is xy. That's wrong. Cannot be xy. They are unlike terms. This term is x, this is y. They may have the same power, but they're unlike terms, and you can't add unlike terms. So this remains just as it is. X plus y. We can do nothing. Can we add these two? No. It's 2 plus x, so it's not 2x. It's not 2x. It is, the answer is 2 plus x. We can do nothing. What about this? X squared plus minus x. So what would you say? Is that minus? Is that x? Do we subtract x from x and get x, or do we get 0? Cannot do anything. Well, we can do something, but we're not going to do it now. They are unlike terms. Even though they're x and x, they have different power. So like terms are terms with the same base, same x, same variable, same power. Different power, we can't add them. We will have to factorize them later. So what about this? Minus 6y minus 8y minus y. What do we do there? We're operating on terms with the same base. Are they like terms? We're operating on terms with the same sign, sorry. Are they like terms? Yes, they are like terms. So what do? We add them and retain the sign. So I'll do this one, you do that one, and this one, and that one. You do those. So this would be a minus 15y. Okay, what about this? 3y squared plus 4y squared. How does that work? Well, do they have the same, is it the same variable? Yes. Do they have the same power? Yes. We can add them. And we'll get 7y squared. Note, addition don't change the power, right? We just put back the power 2. What about these? Can we operate on these? Yes, we can. They have the same variable and the same power. So we have minus 2 and this will be minus 9. These two in front will be minus 9 plus the 10x squared. So now we're operating on terms with different signs, so the answer is just x squared. What about this? 6a squared b minus 2a squared b. Are these the same variable? A squared b and a squared b? Yes, they are. So can we operate on them? Yes, we can. I want you to note how I'm approaching every question. I'm asking, are they like terms? If they are like terms, then we can add them. We look for the sign in the middle. This is addition, subtraction. We're asked to subtract. If we ask to subtract, we can only subtract like terms. So, are they like terms? Yes, we can. Yes, they are. So we can subtract them. This becomes 4a squared b. Are these like terms? Let's see. Y square x, y square x. Yes, they are like terms. As much as they are in different position, the x has a power 1, this x has a power 1, this y has a power 2, this y has a power 2, so they are like terms. This answer is 10xy squared. So the position shouldn't fool you or confuse you. So this long thing here, these two are unlike terms, a squared b, ab squared. But there's an a squared b, so we can group them. So this is 7a squared b plus the 2a squared b plus the 5ab squared. This is ab squared too. We can group that with the 5. This is 12ab squared. This 3a squared b squared. This has nothing in common with the others. So this one has to stay by itself. We can add these two. This will be 9a squared b. Look at the sign here, operating on terms with different signs, so we have to subtract these terms. So this becomes minus 7ab squared, and this at the end here, a squared b squared. Well, that cannot be added or subtracted with any other because it's different terms. So that's the basics for addition and subtraction. You can only add or subtract like terms. If the terms are unlike, if they don't have the same variable or the same power, you can add them or subtract them. Multiplication is different. We said that multiplication and division can affect the power. So x multiply x is x squared. We're adding these powers up here. This is one of the laws of indices. When multiplying terms with the same base, same variable, you add their powers. So that's how you get the square at the top. And for algebra, remember x plus x. When adding terms with the same when adding like terms, we add their coefficient, the one in front. So 2x. So for addition, we add the coefficient, and for multiplication, we add the power. So x times x times x is x to the third power. Add the 3 ones at the top. 2 times x is 2x. We write it like that. So whenever you see 2x or xy or anything like that, note that there's a multiplication sign between. 3 times 2x is 6x. We multiply the number times the number. 4 times 3x, 4 times 3 is 12, and x times x is x squared. Simple. 2 times 5, and you should stop and try to solve it. Right? 2 times 5 is 10. X squared times x to the third power is x to the 2 plus 5 is 2 plus 3 is 5. So we add the powers when we're multiplying. X times y is xy. X plus y is not xy. X times y is xy. 3x times 5y is 15xy. Because x times y is xy. And what about this? A half of p times 8q. Well, a half of 8 is 4, and p times q is pq. This example, 4x squared y cubed times 3x cubed y. 4 times 3 is we multiplying the individual variables and numbers. 4 times 3 is 12. X squared times x cubed is, we have that up here, x to the 5th power. Y cubed times y to the 1 power, we don't put the 1, is y to the fourth power. So the answer is 12 x to the fifth y to the fourth. What about division? If for multiplication we add the powers, what do we do for division? We would subtract the powers. So x squared divided by x squared. Anything divided by itself is 1. Alright, but let's see how we get that 1. It will be x 2 minus 2. 2 minus 2 is 0. Anything to the 0 power, this is one of the other laws of indices. Anything to the 0 power is 1. Or you can do it like this. X squared divided by x squared, x cancel with x cancel with x, we have 1, 1. 1 divided by 1 is 1. So what about this? 6a divided by 2b. Okay? Well, we know the numbers can divide the numbers. 6 divided by 2 is 3. So what is a divided by b? It is a over b. 18 p squared q cubed divided by 3p. I think this was supposed to be q. Alright? So 18 divided by 3 is 6. P divided by, well, this 2 will be subtracted by that 1 power there, so we'll have p there. And this q to the third power will be subtracted by that 2, so we'll have 1 power again there. So 6pq. Alright, so we look at something else in algebra. So that's the basics for addition and subtraction. So we look at now the distributive law. When anything that is outside of the bracket, we know that we have to multiply each term inside of the bracket by that term outside. So x bracket a plus b is x times a plus, put back the sign, x times b. This is ax plus bx. Why did I put the x to the back? You know, it's alphabet. X comes after those other two. 5 times x times 5. 5 times 5 times x plus y. So 5 times x is 5x and plus 5 times y is 5y. You will need to remember this when we do factorization. 3 times this will be what? Well, you can do these two. You can do this one. I'll do this one. Minus 8 times 3a. Minus 8 times 3 is minus 24. Let me put back that a. Minus 8 times minus 2 is positive 16b. Okay? So let's look at this. 3 times 2x is 6x. 3 times y is 3y. 4 times x is 4x, and 4 times 2y is minus 8y. They are like terms here, so we can group them. 6x plus 4x minus 3y minus 8y. This will give us 10x, and this will give us minus 11y. Can we do anything here? No. They are unlike terms. What about this? A half times 2x minus a half times 6y. A half of 2 is 1, so we have just x there. A half of 6, 2 cancels with 2, 2 cancels with 6, gives you 3. It's 3y. Okay, we'll do this and then we'll stop the video. Binary operation. What is binary operation? Binary means 2. So binary operation means to combine two numbers to get a third, and this symbol or these symbols indicate that the operation or what we're doing is binary operation. You look for this symbol first. We combine these two numbers by using this formula, if you want to call it a formula or a rule or an equation. So in this case, x star y is equal to 2x plus 3y. So, and then you have 2 star x, which means that the x is 2 and the y is 5. So we're going to replace x with 2, so it's 2 times 2 plus, and y with 5. 3 times 5. And we get here 4 plus 15, which is equal to 19. This side, on this side, we have a over b is equal to 1/4 of the root of a square minus b square. Might look complicated, but not so. A is replaced by 5 and b is replaced by 3. So let's do that. So this is 1/4 outside. The root of a is 5. So this is 5 square minus b is 3. 3 square. The root of 25 minus 9. 25 square is 25. 3 square is 9. What is 25 minus 9 is 16. And the root of 16 is 4. And 4 goes with 4. And we have the answer being 1. It's pretty simple. On this side, we see a different case. We're seeing, rather than 2 numbers, we're seeing 3. So what do we do when we have 3 numbers? Obviously, we know BODMAS, so we have to work out the numbers in the bracket first. Then we take the answer for that number and replace the bracket here with that answer. Let's see. So we're working these 2 numbers first. So let's say we have, let's work it on this side. 3, the symbol 5, is equal to a square minus b. The a will be the 3 and the b will be the 5. So we have 3 square minus 5. 9 minus 5 is equal to 4. We take that 4 now and replace the 4 where the bracket was, this 4. If it was a 9 or whatever the answer would turn out to be, we put that where the bracket was. If the bracket was on this side here, and that 5 was out there by itself, then we put the 4 or the answer on this side. But because the bracket was on this side, we put the 4 there. Is equal to a square minus b. Well, this is 4 and this is 4. So this is 4 square minus 4. 16 minus 4. And the answer is 12. So there you go for the fundamentals of algebra. The next we'll go to not so complicated stuff.